Querying and reading data from your Firestore database is relatively easy, but it also can be very scary. Primarily because Firebase charges you per document read, and well, if I query 1000 documents and read only one, does that count as one document read or 1000 document reads? Also, what happens if I query multiple sub-collections? Does that affect the speed of my queries? Also, I come from a MongoDB background, so how exactly do I specify which fields I wish to index in my Firestore database? All of these are questions we are going to answer in this video, along with understanding the basics of queries in Firestore. So without further ado, get your coffee ready, I have a double macchiato, open up VS Code and npm install Firebase, and make sure to hit that subscribe button, and let's get started in Firestore queries. Okay, so the first thing I want to show you is the model of the data that we're going to be querying throughout this video. So as you can see, I have a users collection, and inside of the users collection there's 8 documents. Each document will be a user with a custom ID. Now some of these users have a sub-collection while others don't. The sub-collection for these users will be the posts collection. Each user will have certain posts, and each user will also have 3 fields: an age, a name, and a created at timestamp. We're going to be using these fields to query the data throughout this video. So now over in VS Code, I have 2 files, a main.js file and a Firebase config.js file. Now the Firebase config file is a file that I've just created myself, and it just contains all the API keys in order to connect to Firebase. I'm also exporting a constant called app, and I'll use this constant to initialize my Firebase app. Inside of my main.js file, I'm just going to import this app constant, and I'm also going to import get Firestore from Firebase/Firestore. Now we will also need to import many other functions in order to perform certain operations in Firestore, and we will import them as we go along throughout the video. So next I will need to create a constant called db, and I'll set that equal to get Firestore, which will take in the app constant. Now that we've initialized Firebase and Firestore, we can now focus on querying the data. Now reading data from Firebase is asynchronous and will require the await keyword, so I will place all that code inside of an asynchronous function and call it query collection. Now the first thing we'll need to do is reference a collection in Firestore, so we will need to import the first function, which is collection. Now collection takes in 2 arguments. The first is the database itself, which is db, and the second is the name of the collection, and in our case it is users. Now the collection function returns a reference, so I'll create a constant called collectionRef and set that equal to the collection. Next I'll also need to import the getDocs function, and getDocs will retrieve all the documents that we've referenced from this collection. So I will call getDocs with the await keyword, and this takes in the collection reference as an argument, and I'll set that equal to a constant called users. Now since we've provided the collection reference to the getDocs function, it is going to provide us with all the documents inside of that collection. So I'm going to use a for each method to loop through all these documents. But in order to read these documents, we will need to call a method on the user variable, and that method is .data. And finally, I'll just need to call the query collection function, and now inside of my console, you will see I have a list of all the documents from the database. Now one thing I want you to notice is that whenever I check any of these documents, I will not have the sub-collection included inside of it. And that is benefit number 1 with Firestore. Whenever we query for a specific document, it is not going to grab the entire sub-collection with all its documents. So every document that we read, that is the document we get. So in our case, we queried for the entire collection, so we got every document in this collection. Now since this collection only has like 8 documents, that is completely fine. But the thing about collections in a database is it always will increase in its amount. So we never want to be writing code like this, and we always want to limit the amount of documents we receive. Now in order to limit or query for specific documents in Firestore, we need to use the query function. Now in order to use the query function, guess what? We need to import it from Firestore. So I'll import the query function as well as other 3 functions that we'll probably want to use when querying, such as limit, orderBy, and where. So in order to create a query, the first thing we'll need to do is create a constant. I'll just call it q, and then I'll set that equal to await query, because the query function is asynchronous. Now the query function takes in at least 2 arguments. The first is the collection reference. This is the collection we want to query. And then the second argument, or the next multiple arguments, will be the criterias of the query. So I could say, for example, I want to order by the created at timestamp, and I want it to be in ascending order. I can also have it in a descending order if I type in DESC, but I'll keep it in an ascending order, and I could say, for example, I want to limit the documents with the first 5 documents that I find. Now, in order to use this query, we will need to provide it to our getDocs function. Instead of providing the collection ref, we will just provide to it the query, and now over in my console I have 5 documents and they're in a ascending created at order. Now you might be saying, hold on a moment, he still didn't use the where function. I think he made a mistake in his video. Hold your horses for just a moment. I'm just going to use the where function right now. So I came up with a different query. I want to search for any documents where the created at timestamp is in an ascending order. I want to limit it by 5, but I also want to search where the age is less than 30. So that is what the where function does. Now if I go ahead and run my code, I will get an error message telling me I cannot use the query where with the criteria of age and also use the orderBy with the criteria of created at. And the reason for this has to do with the fact that Firestore hates any kind of queries that will take up time. It doesn't matter whether I have a million documents in my collection or just 10 documents in my collection. Firestore will always take the exact same amount of time to find those documents. And the reason for this is because all the fields in every single document is automatically indexed. I have an index for the age field, I also have an index for the name field, and I have an index for the created at timestamps. So what happens when I search for any documents that are less than a given age and also use the created at timestamp? Well, I'll tell you what happens. You will get an error like this telling you that you can't do that. Well, there are certain workarounds in these scenarios. Well, one thing you can do is run 2 separate queries and then filter them out in JavaScript. It's a little bit of extra work, but I mean, let's just face it, Firebase is doing half the work that you would normally be doing if you were using an actual backend. But there are certain scenarios where you wouldn't run into issues like this. You see, I kind of lied a little. As you can see here, it says we're using a filter with an inequality. So what happens if we use a filter with an equality? Well, we can go ahead and try that. It will give me a different error telling me that we need to create an index for this. So if we have scenarios where we're searching for one that is equal to something and we're also ordering it in an ascending or a descending order, in that case we will have to create for that a specific index. And how to do that is just by clicking on this link. You can hold down Control and then click that link, and it will take us up to the Firebase console and it will ask us to create an index. So I'll just go ahead and create an index for this one, and it will take up a certain amount of time. So guess what I'm going to do? I'm going to take a coffee break. Okay, so now that our index has been created, as you can see, we have the index in age ascending order and created at ascending order as well. At this point, if I go ahead and run my query again, I wouldn't get an error message, but I will also get nothing returned because I don't have anybody whose age is equal to 30. So I'll just change this down to 21 for just a moment. And now if I go ahead and run the query again, you can see I have 2 users where the age is equal to 21, and it also listed it out for me in the created at ascending order. Now, based upon these 2 examples we have just taken, one query did not work and the other required an index. Now, you don't have to worry too much about which queries will work. All you have to do is focus on the data that you want to retrieve, and if it requires an index, then just simply create the index. You will always find the link in the console. And if you cannot create that query, then that is the moment where you will have to come up with a different plan. Very rarely you will come across a query that you will not be able to create in Firebase. But hey, in those rare scenarios, that is where you get to show off your JavaScript skills. Now, in this part of the video, I'd like to show you the difference between querying collections and querying multiple sub-collections. And this might come as a surprise to you, but technically speaking, there isn't really a difference between querying a collection or querying multiple sub-collections. So, for example, if I wanted to find a specific user, I would query the users collection to find that specific user. Now, if I wanted to find a specific post for a specific user, well, I can do that just by simply querying to the users collection to find the specific user, then find the post collection inside of that specific user, and then find that specific post. However, sometimes we don't know which user a post belongs to, so therefore we will need to query multiple sub-collections. And in order to demonstrate both these scenarios, the first thing I'm going to do is, instead of import collection, I'm going to import collectionGroup. And also, I'm going to change my function to collectionGroup as well. Now, collectionGroup, like collections, will return a reference to the sub-collections, so I will need to change this from users to posts, because users is not a sub-collection, but posts is. And since my posts documents do not have a created@ timestamp and also does not have an age field, I'll just go ahead and remove those two queries and just leave it limited by 5. Now if I go ahead and run the program, you will notice it will give me the first 5 posts that it could find, and this query spans every single sub-collection. If I decide to remove my limit with 5 and check inside the browser, it will give me every single post document that exists in every single sub-collection. Now you might be wondering, hey, would this affect the speed of my queries because it spans multiple sub-collections? And the answer to that is no, because every single document is automatically indexed by Firestore. I can't emphasize on that enough. So therefore, we don't have to worry at all about querying multiple sub-collections. Now let's talk about the final scenario where I know the user in which I want to retrieve their posts. For example, this could be whenever I enter a specific user's profile page, I will only be able to view that specific user's posts. In order to do this, I would need 2 things. The first is not collectionGroup, but I will need to use collection. And the reason for this is because collection will return the reference for a specific collection, whereas collectionGroup from its name will return the reference to multiple collections, given that they have the same name. I will import collection, but I will also need to import another function called doc. Now doc, just like collection, will return the reference to a specific document. So I will call my doc function and I'll set it equal to const userRef. Now the doc function takes in 3 arguments. 2 of them, just like collection. The first will be the database, the second will be the collection where this document is located, and the third will be the ID of the specific document. Next, I will just go ahead and remove the group from collectionGroup because I'm going to reference a specific collection, and instead of providing just the database, I'm going to provide the collection the user reference. So as you can see here, I'm getting the user reference based upon these 3 pieces of information, feeding it into the collection function to retrieve the sub-collection, and then I'm feeding the reference to the sub-collection into the query, and then the query is retrieving the docs from getDocs. And now if I go ahead and run the program, I will get all the posts that belong to the user with the ID of 002. If I change it to 003, I will get the posts that belong to the user with the ID of 003. If I remember correctly, 002 did not have any sub-collections, so therefore it should return to me nothing, as you can see in the console. Now finally, for the answer to the first question in the beginning of this video, it was the most common asked question and I absolutely have no idea why. If I had 1,000 documents in a collection and I queried these 1,000 documents but read only 1, does that count as 1 document read or 1,000 document reads? I will let you pause the video for just a moment and think about the answer to that question, but the answer is it counts as 1 document read. Now with that said, if you've made it this far in the video, thank you so much for watching. Please make sure to leave a thumbs up and subscribe to the channel. And on that bombshell, thanks for watching again.